YouTube misfits, miscreants, malcontents, and misanthropes. Claire here again, and welcome to my new Friday night series, Travels with Creatards. Travels with Creatards will be a series of very short videos, usually under 5 minutes, and each video will address a single idiotic claim by one of your favorite YouTube Creatards. Tonight, Shock of God. Shock recently made this remarkable claim with regard to scientific evidence supporting biblical truth.
That is awesome. You know, the Bible refers to springs on the bottom of the ocean, like water bubbling up. And how could they know that there are springs on the bottom of the ocean? Yet, scientists discovered that the Bible is accurate. There are springs on the ocean.
Presumably, Shock is referring to Genesis 7:11, which has to do with Noah's flood, and refers to the fountains of the great deep. I think it's also safe to assume that Shock is anxiously awaiting the inevitable discovery of the windows of heaven. Now, what can Shock be referring to when he's talking about springs on the bottom of the ocean? I think he means this.
Hydrothermal vents. Immense chimney-like structures, several stories high, spewing hot water geysers, black with minerals and nutrients.
But there's a little snag with your idea there, Shock. You see, the fountains of the deep added water to the hydrosphere so that there was enough to flood the earth. By the way, there's between 2 and 2.5 billion cubic kilometers of water on Earth, and you need about 4 billion to flood everything, but hey, that's another story, so let's don't get distracted. Thing is, hydrothermal vents like the ones I just showed you, they don't add any water to the hydrosphere. They just recycle water. Let me explain. Hydrothermal vents, as the name implies, pump out superheated water, and they're invariably associated with the mid-ocean ridges or with hotspots like Hawaii. Sediment and rock on the bottom of the ocean is saturated with water, and as that water percolates downward and gets closer to a source of magma, it is superheated and driven upward with great force to form the hydrothermal vents. These hydrothermal vents are the oceanic equivalent of the geysers that we find on the continents. So you see, Shock, your attempt to link hydrothermal vents with the mythology of your favorite bunch of primitive goat herders is the intellectual equivalent of straining at stool. Alrighty then, that's about all I've got tonight. Bis später. Greetings, YouTube misfits, miscreants, malcontents, and misanthropes. Claire's here again with another powerful episode of Travels with Creatards. I'd like to introduce you to Dr. Walter Veith.
I'd like to ask you how old this rock is, and this particular one is a mixture of all kinds of processes, but let's assume for argument's sake it's sedimentary rock. How old is it?
Dr. Veith apparently has a legitimate PhD in zoology, and I think we should give him credit for that. He's also a Seventh-day Adventist minister and a young Earth creationist. As a young Earth creationist, Dr. Veith has major difficulties with geologic time and the idea of a very ancient Earth. He has an entire lecture series on geologic dating techniques, and that includes absolute dating techniques like radiometric dating and relative techniques like the use of index fossils or biostratigraphic correlation. I think at this point I should give you a little taste of the quality of Dr. Weiss' arguments concerning geologic dating.
Is it necessary that the rock is the same age as the fossil? Is that also logical? Well, it could be logical, but is it necessarily right? Of course not. If I have a dog or a cat and it dies, and I bury it in my back garden, is the dog and the cat then as old as the sand that I bury it in? Well, yes or no? Of course not.
Yep, he really did just make that argument. And all I gotta say is...
Deep hurting. Deep hurting.
I can't say I've watched all the Good Doctor's videos so far. I mean, after all, my patience does have its limits, and I do have a gag threshold. But I've watched enough of them to know that I'm going to have to dedicate the next several episodes of Travels with Creatards to Dr. Walter Veith. Dr. Veith is an engaging fellow. He uses a lot of humor in his lectures. He fluffs his audience, if you will. He gets them in the mood. And then he presents his argument. And he often does so by lampooning a technique like, say, biostratigraphic correlation, by explaining it in a very convoluted, confusing manner that convinces an uninformed audience that it's an absurd idea.
Well, science uses the law of fossil correlation in sedimentary rock. So, for example, you go to a rock layer, and you find this fossil. And you go to another area, and you find the same fossil. Then what do you assume? That they are the same age. So how old are they? Well, they're as old as the fossil within them. So this rock over here is as old as this fossil, and this fossil over here is as old as this rock. And because this fossil over here is as old as this rock, therefore this rock is as old as that fossil, and this fossil being the same fossil as this fossil is therefore the same age as this fossil, and the rock within it is also, around it is also the same age.
Alrighty, cutting through Dr. Veith's crapulence, stratigraphic correlation really comes down to this very basic idea. Generally speaking, in a sequence of sedimentary rocks, the rocks that are lower in the rock column are older than the ones at the top. In other words, A was formed before B, B was formed before C, therefore A was formed before C. That's it. This concept was written down as early as 1027 by the great Persian scientist Abu Ali Sina, known as Avicenna, in his vast scientific encyclopedia entitled The Book of Healing. This same idea was named the law of superposition and published a few centuries later by the Danish scientist and bishop Nicholas Steno. Incidentally, thrust faults are an exception to the law of superposition. These occur when mountain building takes place and sedimentary rock layers are shattered and faulted, and older rocks can be thrust over younger rocks. In some ways, Steno was the father of modern geology. Among other things, he theorized that the fossil record was a chronology of different living creatures in different eras. The principle of lateral continuity was another of Steno's idea, and it's simply the idea that sedimentary rocks have geographical extent, and therefore it is possible to correlate rock layers from one area with rock layers in another. And here I've demonstrated it with rocks from Canyonlands National Park and Arches National Park. It was recognized a very long time ago that fossils within sedimentary rocks, like the individual rock layers themselves, have a limited vertical range and a geographic range. Therefore, the fossils can be used to correlate rocks in one location with rocks in another. Apparently, it's well beyond Dr. Weiss's imagination that fossils can have discernible, mappable vertical ranges within sedimentary rocks. I guess he imagines sedimentary rocks are just kind of randomly salted with all kinds of different fossils, kind of like this. Extensive geologic fieldwork over a couple of centuries has, of course, revealed that the fossils of particular plants and animals are not randomly distributed throughout the rock record. Instead, individual fossil groups, individual genera and species have finite ranges in the rock column, and these can be recognized and mapped. And these reveal a sequence of events, a faunal succession. The principle of faunal succession was first recognized by William Smith, Royal Engineer and Geologist, who worked on many civil engineering projects in the late 18th century and prepared the first geologic map of Britain. His ideas about faunal succession were confirmed independently by Georges Cuvier, who worked in the Paris Basin at roughly the same time. And incidentally, their ideas kind of build upon the ideas of the previously mentioned Nicholas Steno. And that, my friends, is why you do not find Homo sapiens with dinosaurs, you do not find porpoises with plesiosaurs, and most assuredly, you do not find Cambrian bunny rabbits. I've got a feeling it would shock the loquacious Dr. Vyth to learn that there's a practical economic application to all this dating and correlating rocks using fossils. There are certain kinds of marine microfossils that are wonderful for correlating and relatively dating sedimentary rock layers. Certain kinds of foraminifera lived in great abundance in shallow Mesozoic seas. They were floating organisms, and therefore they occupied a vast geographic area, and the species evolved rapidly, so they have relatively short geologic ranges. As it happens, much of the world's petroleum supplies were formed in these shallow Mesozoic seas, and they're associated with various kinds of foraminifera. Oil companies drill exploratory wells in an area that they're interested in, and they bring up rock core which contain forams. These forams and their ranges are used to prepare a careful chronostratigraphic record of the area. And it is through these records they identify areas most likely to contain petroleum resources. I believe I can assure you that the oil companies do not invest vast sums of monies on a technique that does not work. Oofta! I've run long. Next time we'll consider the remonstrations of Dr. Vyth concerning radiometric dating. Bis später! Greetings, YouTube misfits, miscreants, malcontents, and misanthropes. Claire here again, and this is another exciting episode of Travels with Creatards. Last week we looked at the interesting ideas of Dr. Walter Vyth concerning relative dating techniques in geology. This week we'll continue with Dr. Vyth, and we'll examine his very amusing ideas about radiometric or absolute dating techniques in geology.
Well, you say carbon dating. Now, you can't use carbon dating on sedimentary rock because carbon dating doesn't go back far enough, and you can't date sedimentary rock in the first place. So if you cannot date it, how old is it? Well, you don't know how old it is. The only thing you can date is igneous rock.
It's like I picked the wrong week to quit drinking.
Alrighty then. Dr. Vyth reveals the limits of his knowledge of radiometric dating right from the get-go. Whereas Dr. Vyth is correct, strictly speaking, you can't radiometrically date a sedimentary rock. You may be able to radiometrically date mineral constituents within the rock. And Dr. Vyth is apparently unaware that there is mineral-specific radiometric dating and there's whole rock dating techniques. Now, dating the crystals within the sedimentary rock won't give you the age of the sedimentary rock, but they will reveal the age of at least some of the mineral constituents within the rock. This is particularly true with a common mineral constituent of sedimentary, igneous, and metamorphic rocks, zircon. Zircons are formed at high temperature and are very stable and very resistant to destruction. Tough little critters are zircons. When the crystal forms, uranium and thorium freely substitute for the zirconium, whereas lead is strongly rejected. Therefore, any lead you find within the crystal structure of a zircon is bound to be the result of radioactive decay. And incidentally, you may have noticed that I mentioned that zircons form in high-grade metamorphic rocks. So Dr. Veith is also incorrect in stating that radiometric dating can only be conducted on igneous rocks.
Let's say it's igneous rock, and you can date it by uranium-lead dating, or one of those techniques. Then how old is it? You still have to use the technique. And the technique tells you, after you've used it, that this rock, for argument's sake, is 350 million years old. Well, they have to make some basic assumptions. They have to assume that at one stage all the uranium in this rock started decaying to this isotope of lead, and eventually you have this isotope of lead in there, and there's a relationship between the amount of uranium and lead in this rock. Does that make sense to you?
So far so good, Doc.
So, if I want to know how old this rock is, I must know some basic things. I have to assume that in the beginning there was no isotope of lead from the decay of uranium. So the lead was not there, the uranium was there, right?
Not necessarily, Doc. There's something called Isochron methodology, and I'm sure you're aware of it, and have chosen not to mention it to the yahoos.
If I want to know how old it is, if I want to know how much time it takes to set a sand clock, you know, I set one of those eyeglass timers, those egg timers, then I know it takes X amount of time for the sand to run from the top into the bottom. Is that right? But what if I had a hole in the top and somebody sneaked more sand in there? What would happen then to my clock? That would be a problem, right?
I think I'm going to spare you guys some time and a whole lot of pain here. Let me just say that Dr. Ugly Suit goes on for several minutes about contamination of samples.
All rock is porous. Well, unless it's vitrified, but it's porous.
No, you're full of crap. There are rocks that are virtually closed systems, including a lot of igneous rocks like granite.
Can I guarantee that nothing ever went out of this rock? If I have rain, and the rain runs through the rock, can the rock elements be dissolved in the rainwater, yes or no?
Rainwater, acidic or not, is not going to remove material from the crystal structure of zircon.
So if I have a whole layer of rocks, and I have acid rain going through it, is it possible to wash some of the lead out of the top, yes or no? Where would most of the lead go then? To the bottom layers. So I take this layer and I send it to the lab, and they say, "Oops, there's a lot of lead in here. This is one old rock."
No, you're more full of crap than the average hog waste lagoon in eastern North Carolina, and I'll tell you why. First of all, if we're talking about a single rock tested by a single method, then contamination may be an issue or it may not. But the number one gets is more suspect than one can get by using multiple methodologies. Here are some of the commonly used radiometric dating techniques. Let us assume multiple techniques were used to date the same sample. Let us assume that the multiple techniques came up with a consistent age for the rock. Given the different half-lives for the various parent elements, given the different daughter elements that result from radioactive decay, what are the odds that the ratios of parent to daughter element in each technique would result in a consistent age across the board for all techniques as a result of contamination? Getting back to our little friends, zircon crystals. I actually use those because zircons are common. I could have used any number of silicate minerals. There are a whole host of minerals that are formed at very high temperatures and pressures, in which uranium or thorium freely substitutes with an ion. And they're almost indestructible. They last a long time, and it's very difficult to alter them in any way. It doesn't matter how long lead in groundwater percolates around them. The lead's not going to be incorporated into the crystal structure of the mineral. And if you don't understand that, then you're either illiterate in chemistry, or you're in complete denial, or you're just lying to suit your customers. Earlier I mentioned something called Isochron methodology. That's a radiometric dating technique that is used to identify contaminated samples, and this is the way it works. Let's say, for instance, that we want to date a rock using the rubidium-strontium method. Rubidium-87 decays into strontium-87, but there's also an isotope of strontium that's not radiogenic in origin, strontium-86. In Isochron method, one does not merely compare the amount of strontium-87 to the amount of rubidium-87. Instead, one looks at the ratios of strontium-87 to strontium-86 and the ratio of rubidium-87 to strontium-86. When a magma cools and an igneous rock is formed, strontium-87 and strontium-86 freely substitute for each other in mineral structures. In other words, the ratio of strontium-87 to strontium-86 in the magma is preserved in the rock. In the newly formed rock, if one took a series of samples, then the ratio of strontium-87 to 86 would be constant throughout the rock. On the other hand, rubidium is taken up at a variable rate by different minerals, and therefore samples would indicate a range of the ratio of rubidium to strontium-86. If one takes a series of samples from an igneous rock with the purpose of dating by rubidium-strontium method, and the rock is uncontaminated, that is, no rubidium's been added, no strontium's been added, and none's been taken away, then if you plot these ratios on a graph, you will get something approximating a straight sloped line. Why? That's because over time the ratio of rubidium-87 to strontium-86 declines because rubidium is decaying into strontium-87. Concurrently, the ratio of strontium-87 to 86 is increasing because more rubidium-87 is being formed. If the samples were contaminated by the addition or subtraction of rubidium or strontium, then the plot of the ratios would not approximate a straight line. In fact, the samples would be all over the place on the graph. In the real world, this method utilizes a large number of samples, not the three I've indicated in my little model. And if the ratios plot as a straight line on a graph, then one is safe in assuming that the rock samples are not contaminated in the way described by Dr. Veith. Therefore, the ratio of parent to daughter element can be used to date the rock. Well, all right then. Until next time, bis später.
Motorcycle with the devil in the seat, doing 90 miles an hour down a dead-end street.
All up the country, baby, don't you wanna go? I'm going up the country, baby, don't you wanna go? I'm going to some place where I've never been before.
Greetings, YouTube misfits, miscreants, malcontents, and misanthropes. Claire's back with another exciting episode of Travels with Creatards. Today will be our third discussion on the fascinating musings of Dr. Walter Veith, failed academic, Seventh-day Adventist minister, and young Earth creationist. Come with me now as Dr. Veith shares his ideas about fossilization, dinosaurs, and one of the most famous rock formations in the world, the Karu supergroup.
If covered by moist sediment, weathering is prevented, and for these reasons, quick burial is perhaps the most important condition favoring fossilization. Quick burial.
That's right, Dr. Veith. Quick burial favors fossilization. It's not crucial, it's not absolutely necessary, it simply favors fossilization.
Question: what buries a dinosaur quickly?
As you can see, Dr. Veith is appealing to his audience's ignorance. Many people imagine, when they hear the word dinosaur, behemoths of the Jurassic and the Cretaceous. Whereas later in his video, when Dr. Veith starts talking about South African dinosaurs, he's talking about some animals that are quite different.
Unless it is some form of catastrophe, isn't that right?
No, and only someone wholly ignorant of fossilization, of dinosaur fossils, and of sedimentology would make such a statement. Unless you're simply telling a fundamentalist Christian audience what they want to hear. One basic fact that Dr. Veith in his stand-up comedy routine overlooks is that whereas it may take a while to bury a very large animal, it also takes a long time to break it down and weather it away. Another simple fact that Dr. Veith overlooks is that large dinosaurs, like our friend the Brachiosaurus, are rarely found intact. More commonly, they're found as bits and pieces of disarticulated skeleton, like, for instance, these fossils at Dinosaur National Monument.
But we saw that the majority of fossils are in watery sediments, water sediments.
Well, Dr. Veith, if it's a sediment, there aren't a lot of options. I mean, there are clastic sediments, that is, sediments that are formed by the physical breakdown of pre-existing rock, and often these clastic sediments are deposited in aqueous environments. Of course, there are lots of aqueous environments: oceans, lakes, streams, swamps. And then there are windblown sediments, that is, aeolian deposits, like the Navajo sandstone. And there are biogenic sediments, formed by, for instance, microorganisms constructing little calcareous shells which rain down in the ocean and form limestones of certain kinds. And some sediments are deposited by glaciers.
And what is even more interesting is the fossils are orientated.
I should interject here for my audience that what Dr. Veith is referring to is dinosaur fossils in general. And what he just said is, to put it charitably, the byproduct of a very bad dog.
If you go to the Karu and you look at the fossils of the dinosaurs, and that's the best dinosaur area in the world.
Sorry to keep interrupting, Doc, but the Karu is an enormously thick sequence of rocks representing a wide range of environments through a vast amount of time. And the dinosaurs only occur in the upper 10 million years or so. The vast majority of fossils predate dinosaurs. But you go ahead with your little story. We'll get back to the Karu later.
Then you will see that the dinosaurs are lying in a particular direction. Now you could assume that whenever dinosaurs died in the past that they always fell over in the same way.
Or one might assume that you don't know what the hell you're talking about.
That's a possibility. But there might be another solution, and that is that they are stream orientated. Do you think that sounds logical? That they are stream orientated, that they are washed into position.
The Karu represents approximately 120 million years of geologic history of South Africa. And Dr. Veith has chosen to focus on one brief period, a 10 million year period near the end of sedimentary deposition in the basin. So perhaps it's time I gave you a little rundown on geologic history within the Karu. The oldest rocks in the Karu Basin are the Dwaika group. And the Dwaika represents a time of continental-wide glaciation because South Africa at that time was located at or near the South Pole. Continental glaciation lasted approximately 40 million years, and then the rocks of the Dwaika give way to the Eka group. These are shallow marine sediments and also coastal floodplain sediments. Within these rocks, one finds fossils that are important to the history of the idea of continental drift. For example, the little marine reptile Massosaurus, which is found in South America and Africa, and also a widespread plant called Glossopteris, found on all the Gondwanaland continents. Succeeding the Eka group are the rocks of the Beaufort group, and these represent some of the most fossiliferous rocks on the planet. When one hears of billions of fossils within the Karu supergroup, most of these fossils occur within the Beaufort. These rocks predate dinosaurs by many millions of years, and most of the fossils are mammal-like reptiles. The largest creatures at this time grew to a length of about 5 or 6 meters. More typically would have been cow-sized creatures like muskox here. The environment at the time would have been a vast, well-watered fluvial plain. The Beaufort group rocks are a wonderful place to see the law of faunal succession illustrated. They're so fossiliferous that it was not difficult to establish distinct fossil assemblage zones, one succeeding another. And I believe Dr. Vythe is well aware of this fact and has chosen to ignore it. Let's go back to one of Dr. Vythe's funny lines earlier.
Question: what buries a dinosaur quickly?
Well, first off, let's consider the environment in which these creatures lived. When the dinosaurs of the Karu lived, the area remained a vast fluvial basin. And one can imagine that dinosaurs frequently died in a situation something like this. It's not unusual for carcasses in a situation like that to be oriented by the flow of the stream, and it's not unusual for them to be caught in vegetation near the shore or on sandbars and buried. And that's certainly a plausible situation with regard to the Karu dinosaurs, particularly since they're not the building-sized behemoths that Dr. Vythe's gullible clientele imagines. In fact, they're more like this. One of the largest dinosaurs of the Karu is Massospondilus, and these critters lived early in the reign of dinosaurs in the early Jurassic, prior to the emergence of the truly gigantic dinosaur forms. Massospondilus grew to a total length of about 6 meters, which means that it was roughly equivalent in size to a white rhino. Of course, the white rhino is probably far more massive than the dinosaur. As with dinosaur fossils elsewhere in the world, dinosaurs of the Karu are rarely found complete and intact. Here's a fairly typical fossil. Ardonyx is a close relative of Massospondilus. At this point, I've watched a number of Dr. Vythe's shoddy videos, and I'm no longer willing to give him the benefit of the doubt and consider him merely ignorant or in denial. He has access to this information. He knows these things. He's choosing not to share them. He's choosing to sell a gullible, unsuspecting audience his snake oil. And the proper response to snake oil salesmen is illustrated in this little video clip.
Your young friend can use some help. This is it. $1 a bottle. It works wonders on wounds.
Works wonders on just about everything, huh?
It can do most anything.
How was it with stings?
All up the country, wherever that you wanna go.
point where the cursor is now is 21,346 feet below sea level.
Oh shit! Nefellum Free has discovered Google Earth!
No! 21,000 feet down. It's estimated that approximately half of the world's water was once inside the Earth and is now in the ocean floors. What happened is this. The Earth split open at the seams which run around it like the seam of a baseball. When this happened, the water gushed out at supersonic speed with tremendous pressure applied on it. And as it emptied onto the Earth, it left space, empty space inside the Earth. And the gravity of the Earth, the weight of the rock bearing down upon it, caused the ocean floors to sink and fill that empty space vacated by the water which came out of the Earth. And that's why the ocean floors sank and the continents ground their way across the face of the Earth.
It's funny you should mention gravity, Neff, because gravity has everything to do with how our planet is structured. Let me explain. Neff, we can only hope that even you are aware that the Earth is made up of distinct layers, and these formed at the time the planet coalesced, with denser material sinking toward the center of gravity. Oceanic crust averages about 3 grams per cubic centimeter in density. Continental crust is somewhat lighter at 2.7 grams per cubic centimeter, and thus continental crust is topographically higher than oceanic crust. It has nothing to do with the collapse of oceanic crust.
Even evolutionists agree that this world once had a supercontinent called Pangea.
Actually, that's pronounced Pangea. Pangea. And it's a supercontinent that formed during the late Paleozoic and then broke apart during the Mesozoic. It's not the first supercontinent, by the way. Rodinia predates it. And there are probably other Precambrian supercontinents. That's Pangea.
And it blew up. The Earth blew open at these ridges, and the continents slid away from these ridges during the flood of Noah.
If I may sum up, you're suggesting that this cataclysmic, unprecedented event swept across the planet, moved billions and billions of tons of continental crust, thousands of kilometers, totally reordered our whole planet, obliterated pre-Noachian society. There's no hint of a village, nothing in the fossil record to indicate these people ever existed. And yet this tiny boat, constructed with at most Bronze Age technology, bobbed peacefully on the waves and survived intact.
Now recently a couple of novice evolutionists on YouTube have concocted little garage models attempting to refute the fact that the tremendous pressure bearing down upon the water inside the Earth could have caused it to eject from the Earth with enough velocity to exit the Earth's atmosphere.
Actually, they just tried to explain some basic physics and hydraulics to you.
They're not taking into account everything in physics.
That'd make a cat laugh.
What math or physics do you know? You couldn't balance a checkbook.
Now initially when this water began ejecting from the Earth, it would have boiled into steam almost immediately because of its tremendous speed and the air friction.
Actually, chump, it would have been released as steam for a very basic reason. Let's go back to our little model of the Earth's layers. As we go deeper into the Earth, things don't just get denser, they get hotter. A lot hotter. Since you've pretty much purloined Walt Brown's hydroplate model, let's take a look at that. Walt maintains that initially there was this subterranean layer of water underneath the world's crust. In non-tectonically active zones, temperature increases at depth by about 25 degrees centigrade per kilometer. Continental crust averages between 30 and 40 kilometers. 25 times 30 equals 750 degrees Celsius. You want me to explain what happens to the entire world's population, including Noah et al.? Here it is. As I observed earlier, as we go deeper and deeper in the earth, the materials get far denser. Water is much less dense than crust, continental or oceanic. So there's no natural explanation for there being a layer of water beneath the crust. Right away, you're required to invoke a miracle. And that's the problem with you guys. You always want a naturalistic explanation for all these things, but the moment you run into a bumpy patch, right away, you're required to invoke a miracle. Let's not equivocate here, Neff. You're a clown. Why do you suppose the world's industries, institutions of higher learning, government, hire qualified physicists, geologists, biologists, chemists, instead of you? And by the way, how's the job search going?
Yes, it's true. This man has no dick.
I'm going up this country, baby, don't you wanna go? I'm going up the country, baby, don't you wanna go? I'm going to some place where I've never been before.
This video is a response to a question posed to me by a YouTube friend of mine goes by the name Sunny Delight. He had sent me a bit of an article by uniformitarianists, evolutionists you might call them, in which they describe how the Hawaiian Islands supposedly formed over vast amounts of time. There is no scientific evidence to support the claim that the Hawaiian Islands or any other island rose over vast amounts of time.
This could very well be the stupidest person on the face of the earth.
The Hawaiian Islands rose probably at the end of the Noachian flood as the plate of the earth moved over a hot spot. The Hawaiian Islands rose as the plate of the earth moved across a volcanic hotspot, which was you might say, a corpuscle of magma that was created in the earth by the plates grinding one across into the other. And it bubbled up, and as it bubbled up, bloop, you have one island forms, it moves a little further, and bloop, another one forms behind it, and then bloop, another one behind it.
Well, that's fascinating, Sugar Britches. But I have a couple of observations concerning Hawaii and the Hawaiian archipelago. If you go east to west, thousands of kilometers, by the way, what you find in the east is a series of active volcanoes on the big island of Hawaii. The islands to the west don't have active volcanoes, and they're much more eroded. than the island of Hawaii. And this erosion gets progressively more extreme as one moves westward. For example, to the west of the Big Island is Maui, and Maui is a substantial island itself, but it doesn't have active volcanoes, and erosion is becoming quite noticeable. There are severe cliffs, and bits and pieces are beginning to drop into the ocean. As we move a little farther west to Kauai, then the erosion is much more marked, and the island is somewhat smaller. Somewhat to the west of that is Nihoa, which is quite a small island. There really isn't a lot left of Nihoa. Now, moving quite a bit to the west, here is Lisan Island, and Lisan has pretty much been eroded down to sea level, and there's just a bit of it left. You might notice that breakwater around it. That's a coral reef, and maybe I'll talk about coral reefs here in a minute. Continuing west, this is Kure Atoll, and there's virtually no land left. There's a tiny little island there on the right side of the screen. That's Green Island. But there is a substantial coral reef that grew around the island that once existed, and it is thriving. I don't really see how your young Earth model accounts for the growth of that coral reef and the fact that this substantial volcanic island has had time to completely erode away. Your bloop bloop model, as I like to think of it, is pretty silly itself, but the coral reef and the fact that the island has eroded completely away seem pretty damning to your young Earth model.
Okay. The evolutionist or uniformitarianist believes that these islands took hundreds of thousands, or I think the vast majority of them believe millions of years to form. This is completely false, and it's not even supportable by science, and here's why. In science, we observe that islands rise quickly. Many islands have been observed to rise quickly in a matter of a few decades, some of them just a couple of years, others months, some of them weeks or days. The island of Surtsey rose over a period of just a few years, and it's already got a considerable variety of plant and animal life on it, species. And guess what? It's got millions, I'd say millions of strata. As far as 800 meters below, they've drilled 800 meters below the island and found nothing but strata.
Neff, now you're just lying your ass off. You know as well as I do that Surtsey was simply a volcanic vent that opened up during the 1960s on the vast Icelandic shield. It just happened to be a little bit below sea level, like a few dozen feet below sea level, and those millions of feet of strata that you're referring to were already there a long time before Surtsey ever formed.
And see, the evolutionists, the uniformitarianists, believe that these strata formed over vast amounts of time, hundreds of thousands to millions of years. But the island of Surtsey rose in no time whatsoever, and it's got millions of strata.
Sugar Riches, you have got to be the biggest colostomy bag on YouTube. Okay, let's play on your pitch for a second. I'm going to tell you a few things about Surtsey and Hawaii that you obviously don't know. And I'm going to use a creationist source to help us here. Alrighty, I looked at one of your favorite sources, Answers in Genesis, and I found an article by someone named Dr. J. Osgood, originally published in Creation magazine in March 1981. It's entitled The Date of Noah's Flood. And according to the esteemed Dr. J. Osgood, it happened approximately 4,300 years ago. Now, the Big Island of Hawaii, and I'm not even talking about the rest of the archipelago, the other islands, nothing, just the Big Island alone, comprises about 39,000 cubic miles of magma. That's 5.8 trillion cubic feet. If the volcanoes of the Big Island of Hawaii erupted continuously since the time of Noah's flood, that means that they pumped out 1.3 billion cubic feet of magma per year, or 3.7 million cubic feet per day, 152,000 cubic feet per hour, or 2,500 cubic feet per minute for the last 4,300 years. That's how much magma it would have to produce to form the island of Hawaii. And as I said, I'm not even talking about the rest of the islands or the entire Hawaiian archipelago. Perhaps it's time I gave you a little perspective on the island of Hawaii compared to the island of Surtsey. The island of Hawaii is over 10,000 square miles in extent, whereas the island of Surtsey at its greatest extent was 2.7 square miles, and it's currently much smaller because it's being eroded away by the ocean. The highest elevation on Hawaii is over 14,000 feet above sea level, whereas Surtsey is a little over 500 feet above sea level. Measured from the sea floor, the island of Hawaii is over 33,000 feet high, whereas the island of Surtsey, measured from the sea floor, is a little over 900 feet. As I said earlier, the total volume of the volcanoes of Hawaii is about 39,000 cubic miles. The total volume of Surtsey is about a quarter of 1 cubic mile. I gotta say, Neffy, the most asinine thing about your massively ridiculous video was your attempt to assign millions of cubic miles of magma, which make up the entire Icelandic landmass, to this tiny little island that formed in the 1960s. What the hell is wrong with you? Seriously, have you suffered a brain injury at some point?
Monica, oh, wiki wiki, she was dancing over me, and I set her skirt on fire on that beach at Waikiki. I'm going up the country, baby, don't you wanna go? I'm going up the country, baby, don't you wanna go? I'm going to some place where I've never been before.
Now, think about what they just said. Folding bends many layers of rock without breaking them. What you just heard is the most cockamamie, poppycock, impossible thing, lie, stupid thing any evolutionist has ever said.
And yet, over many decades, hundreds and hundreds of experiments on all kinds of rocks have been conducted, and they all demonstrate that all kinds of different sorts of rocks, when subjected to high confining pressure, like in a tectonic event, and high temperature, like rocks when they get buried at great depth, become very ductile. They become enormously plastic, and they do, in fact, bend. And these articles are not difficult to find. There are research articles all over the place. You could probably get access to them through your local library. You can even find some of them on the internet. The fact that you have not done so, Neff, tells me that you either haven't done your research, you don't want to know, or you looked at the math in some of these guys and you got scared.
I think it's important that I pointed out that NASA webpage made the claim that mountains can fold without breaking the rock. That's not even common sense, folks. And it's not possible either.
And therein lies why we find you so obnoxious, Neff. Here's something you clearly don't understand. You are incredulous about. But you don't ask a question, how is this sort of thing even possible? No, you just make a blanket statement that it's impossible because it doesn't fit in with the mythology of some ancient desert-dwelling sheep herders.
See, this is conclusive proof that every mountain range and every mountain of the earth rose in virtually no time at all. So fast, in fact, that gravity did not have time to suck the water out of the mountain. The strata from the bottom of the mountain to its very peak were plastic as the mountain rose fully.
I think you have a rather cartoonish image in your head of how folded mountains get formed. It isn't simply that the sediments are squeezed together and pushed upward into folds. That's not how it works. Actually, the rocks are being pushed downward to great depth, and under high confining pressure and temperature, they become very plastic and they fold. As erosion removes overlying material, this material forced to depth, which is actually depressing the rocks of the mantle, which are far more dense, begins to rise. And as it rises, continued erosion creates the ridges and valleys because of differential weathering of different types of rock, because some rocks, like sandstone, are very resistant to weathering, while lots of rocks like limestone are less resistant. It's like the Great Valley of Tennessee, where the valleys are limestone and the ridges are sandstones and metamorphics and in some cases granites. Alrighty, Nefster, what's the ultimate proof that these folded mountains were subjected to huge pressures and heat? Within the hearts of all these mountain chains, the rocks have been so intensely deformed that they've actually been chemically altered. They've been metamorphosed by the heat and pressure. And minerals that only form under gigantic pressures and heat are present in these rocks. Minerals like staurolite, kyanite, andalusite, sillimanite. There's your proof, Neff. And if you knew even the first thing about rocks and geology, you'd have known that. Now let's briefly look at your model of how folded mountains occurred. According to you, the North American continent was forced westward from the mid-Atlantic ridge and eventually encountered obstacles or friction that pushed up the mountain ranges. So according to you, the Rocky Mountain chain, the Basin and Range province to the west, and the Sierra Nevada to the west of that, and finally the coastal ranges of California were all forced up into folds in the same titanic, earth-shattering event. But so were the Appalachians. How is it that the entire center of the continent escaped this carnage? How is it that the rocks are relatively undisturbed, flat-lying, and have very little topographical relief? And then suddenly, on the trailing edge of the continent, away from where all the friction and deformation should have occurred, we find the Appalachians. How about this area in the circle, Neff? This is the Basin and Range province, and these mountains and valleys are not created by folding of sedimentary rocks. Instead, they're created by faulting. North-south trending faults that create uplifted blocks and downlifted blocks as the continent of North America slowly pulls itself apart. How does that fit in with your rapid creation of folded mountains, Neff?
Many of them contain erratic boulders trapped inside the mountain at various levels in the strata.
Bullshit, Neff. You're talking straight out of your ass. And I do believe I've looked at a lot of more rocks and a lot more mountains than you have.
The evolutionists at NASA made a crazy, absurd statement that is actually a lie, made in the name of uniformitarianism and evolutionism.
No, chubby hubby. They simply made a statement based upon massive amounts of field work over a couple of centuries, incredible amounts of research and experimentation in laboratories, and some basic chemistry and mineralogy. And you can't accept the simple facts because it contradicts your desperate clinging to the myths of some ancient sheep herders. You'd rather believe that some uneducated Bronze Age sheep herders know more about the structure of the earth than modern geology. You're pathetic. Neff, I honestly don't know how many more responses of this sort I can make to you. Frankly, you bore the shit out of me. You know nothing. You're arrogant as hell. You dismiss the education and real-life field experience of people who have dedicated their life to this field. You're unwilling to become educated. You just may well be the saddest bastard on YouTube. The only reason I've responded to you lately at all is people keep requesting that I respond to you. Do us all a favor. Get off your spotty ass, put down the headphones, get out of that dark and lonely room, and find yourself a fucking life.
Well, he's just an excitable boy.
Tonight's episode of Travels with Creatard brought to you by Neverclear, the preferred drink of 9 out of 10 YouTube Creatards.
No bad taste, no after effect, no upsetting the nerves. Just a nice, smooth drink.
Never say never, YouTube. Here I said I wasn't going to talk about Nefellum free anymore in these videos, and what am I doing? I'm talking about Nefellum free. The reason is, apparently I got under his skin somewhat. And, since unlike me, Excitable Boy doesn't have to work for a living, he's got nothing to do with his time but sit around pissing the night away on YouTube. He's released a veritable Noachian deluge of bullshit. And I thought I'd take a few minutes to address some of his points. Now, let's start out by talking about Aeolian sedimentary deposits. You had a couple things to say about those. Let's look at the first one.
So Claire, here's the definition we're looking for, okay? It's number 2. A sheet-like mass of sedimentary rock or earth of one kind lying between beds of other kinds. The key word here, Claire, is sedimentary.
The manner of deposition is often in water, as you pointed out, but there are many aeolian or wind-blown deposits that have been lithified into rock and are found in the stratigraphic record. Perhaps we'll talk about how we identify those a little later in the video.
Sedimentary, Claire. So when I said in my video that all strata are created by and in water, that is exactly the truth.
No, you haven't got a clue as to what you're talking about, but go ahead.
Strata are created by water. Aeolian layers are made by wind.
Sugar Britches, you sure are hung up on the difference between layer and stratum. Tell you what, since you've been referring to dictionary definitions, let's use this one. Oxford English Reference Dictionary, Rule Britannia, I say. Now what does it say about stratum? Stratum. A layer, or set of successive layers of any deposited substance. Are you familiar with the expression buggered? Neff, assuming that you recovered from that anal probe, what else you got about sedimentary rocks?
Because the Earth's been globally flooded? Did you know, Claire, the Earth is covered with sedimentary material to an average of over 1/2 mile deep? Wow!
Neff, there are many regions of the world that aren't underlain by sedimentary rocks. And if you don't know that, you're even more grossly ignorant than I had imagined. There are areas that are exposed bare, igneous, or metamorphic rocks, like, for example, the Sierra Nevada. There are areas that have a thin veneer of soil, but they're underlain by metamorphics and igneous rocks, like the Blue Ridge. There are ancient cratons, like the Canadian Shield, underlain mostly by metamorphics. There are many volcanic areas, almost entirely made up of volcanic rocks. This is pitiful, Neff. I mean, this is starting to remind me of that nonsense you were spouting about the erosion of the Hawaiian archipelago. I mean, that was stuff that wouldn't just make a geomorphologist laugh, it would make my cat laugh.
You mentioned aeolian deposits. Truly, there are layers of sand created by winds. There is such a thing as aeolian process, but it has not created the sandstone that we see in this world. Okay, uniformitarianists like yourself point to the sandstone mountains around the world and claim they were created by aeolian process.
Don't know anybody who's talked about mountains formed by aeolian processes, Neff. I think you're just kind of making that up. Big surprise. But there are sandstones in the world that clearly were formed by aeolian processes, specifically in deserts. And the cross-bedding in desert sand dunes has an inherent difference than the cross-bedding in, say, deltas. The angle of repose of layers in sand dunes is typically much steeper, upwards of 35%, than the angle of repose of layers, or strata if you prefer, in deltas, which is down around 20 to 24%.
Guess what you're looking at right now? You guessed it. Stratum.
Neff, you keep saying stratum for multiple layers of rock. Stratum is a single layer. The plural is strata. Also pronounced strata.
This is sandstone, Claire. Now, how do we know that this was formed in water?
Well, you don't know, but you presume it was deposited in water because you imagine that all sand is deposited in water.
By looking at it, for one thing. But also, Claire, because guess what? We often find fossils in sandstone.
I don't know for sure, but that looks a lot like the Navajo sandstone. Assuming that is the Navajo sandstone, I don't believe you found that fish fossil in it. That one appears to come from the Green River Formation, which is Eocene in age. And sandstones are formed in all kinds of ways in all kinds of environments, and they're not all fossiliferous. And by the way, I think you misunderstand something about sandstone or sand. That's merely a designation based upon the size of the particles. It has nothing to do with the depositional environment.
Yeah, lots of them, in fact, including Cambrian creatures like these. And also dinosaurs. That's right, dinosaurs in sandstone. So much for your imaginary geologic column, Claire.
I do believe that Neverclear is getting to your head, Neff, because that didn't make a lick of sense. Look, sand is deposited in a lot of environments, including fluvial environments, lacustrine environments, that is lakes, floodplains, in other words, sources of water, places where animals gather. Presumably dinosaurs gathered at water holes and whatnot, and sometimes they died. And sometimes their bodies were washed into the stream and caught on sandbars and whatnot and buried. You ought to read more. For instance, this would be a good article for you to read. This is about the depositional environment of the rocks in Mongolia where certain dinosaurs were found, including Protoceratops and the famous Velociraptor, Oviraptor, Pinacosaurus. Guess what? They were mostly aeolian deposits. In other words, a semi-arid to arid environment with lots of sand dunes that occasionally collapsed on the poor, unfortunate critter nesting below it.
Well, he's just an excitable boy.
Man, the more responses I see from Nefellum free to me, the more I suspect the man is the bastard spawn of the Energizer Bunny and a manure spreader. Who knows what he could have accomplished if he had not gone insane and fallen prey to John Barleycorn. One of Neff's favorite tactics, and I think it's taken from the Creationist playbook, page 105 or some damn thing, is to take something you've said and carefully edit it, take it out of context, so that instead of replying to the point you were making, reply to the point he wishes to reply to. For example, I recently said this: you're suggesting that this cataclysmic, unprecedented event swept across the planet, moved billions and billions of tons of continental crust, thousands of kilometers, totally reordered our whole planet, obliterated pre-Noachian society. There's no hint of a village, nothing in the fossil record to indicate these people ever existed. And yet this tiny boat, constructed with at most Bronze Age technology, bobbed peacefully on the waves and survived intact. But Neff did not respond to that point. No, he edited it so that he responded to a completely different point. Let's look at his edit. Obliterated pre-Noachian society. There's no hint of a village, nothing in the fossil record. Wow. It's been a long time since I've seen the spark plug and the Carl bow hammer. Even Answers in Genesis says they're bullshit, Neff. And I'm surprised you sink so low as to use them, because I know that you steal Answers in Genesis material shamelessly. Let's talk about the hammer first. I refer to the hammer as a Carl Baugh hammer because it's owned by Carl Baugh, a young Earth creationist who's one in a long series of young Earth creationists who claim all sorts of academic degrees he doesn't actually possess. The hammer was found in 1936, and it's apparently a 19th century miner's hammer, and it's been coated with limestone because it was apparently dropped into a crevice in a mine, and a concretion of limestone has formed around it. Anyone who's the least bit familiar with mines or with caves know that concretions are common. Concretions are very common in mines and caves. Wherever groundwater interacts with soluble minerals, it can take the minerals into solution and then, under slightly different conditions, redeposit them. If you've ever watched any marine archaeology programs, like, they're recovering cannon from a pirate ship, or maybe recovering artifacts from the bottom of the Mediterranean, the material is commonly coated with limestone concretions. One of the more interesting examples of concretions are some World War II era bombs in a swamp in England, where the steel of the bomb casings has reacted with swamp water to form concretion called siderite, which is an iron carbonate. With regard to the spark plug in limestone, I'm going to defer to a much more accomplished YouTuber than myself. And this is from a video by Potholer54 Debunks. I hope you'll forgive me for the use of the material.
Inside were the remains of some form of mechanical device. The device consisted of a 3/4 inch wide cylinder made of solid porcelain or ceramic, and in the center of the cylinder was discovered a 2 mm thick shaft of bright metal. This shaft was magnetic and showed no signs of oxidation. Circling the ceramic cylinder were rings of copper. X-rays taken by the Child Ford Society indicated that to one end of the metallic shaft was affixed a spring or helix of metal. Indications are that it is some form of electrical instrument, otherwise known as a spark plug. The artifact itself has been lost, but when Pierre Stromberg of Pacific Northwest Skeptics sent X-ray photos of it to the president of the Spark Plug Collectors of America, he wrote back, "I knew what it was the moment I saw the X-rays, a 1920 champion spark plug."
Carbonate concretions can form fairly quickly around modern objects. This is well understood, and it most certainly does not bolster your young Earth creationist cause, Neffy. In closing, I want to say that you made one statement in the video that I borrowed from here that bemused me greatly, and here it is. What precisely are you referring to when you refer to the Cretaceous layer? Cretaceous is a geologic period. It's also a stratigraphic system. It consists of many layers, many strata of rock. So, unless you're referring to some sort of Mesozoic chicken, I have no idea what you're talking about.
Welcome to the 3rd annual Golden Crocoduck Award.
That's right, the most prestigious award in creationism is here again. It's time for the coveted Golden Crocoduck 2010.
Heaven is a place where nothing ever happens.
When a Creatard achieves a Golden Crocoduck Award from Potholer54, I guess there's just not that much more I can say except salute! Congratulations, Neffy. I can't think of anyone who deserves it more. I kind of feel Neffy owes me a little thank you for prompting him to produce some of the finest examples of brain-dead, knuckle-dragging, Creatard fucknuttery on YouTube this year. Not that I'm going to be waiting on Neffy's call, but I believe with the Golden Crocoduck Award, my work is finished with Neff. It's time I moved on. But not to worry, because I know a whole new crop of Creatards that I'll be pwning in the near future. Before I leave, though, I wanted to clear up one final question that Nefellum Free asked me recently. Neffy posed a question to me concerning something he called the Cretaceous layer. I made a joke about it involving chicken, but I must admit to have been a bit bemused, because to me, Cretaceous is an entire system, a stratigraphic column of rocks representing the Cretaceous period, which ran from about 145 million years ago to 65 million years ago. But in checking a bunch of Creatard websites, I found out when they talk about Cretaceous layers, They're talking about the late Cretaceous chalks, which, after all, give the Cretaceous its name. Creta is Latin for chalk. As a matter of fact, the geologic symbol for the Cretaceous is K, and that comes from the German word Kreide, which means chalk. These Creatard websites talk about the Cretaceous chalks as if it's a deep geologic mystery, and that it somehow supports their flood myth. Apparently they haven't read in geologic literature for the last 25 years, because that mystery was solved quite some time ago, and that's what this video is about. Now, the first thing I need to explain about chalk is that it's almost pure calcium carbonate. In other words, it's not contaminated with a lot of silt and sand and stuff washed off the continents and into the ocean basins. And it's extracted from seawater by some little microorganisms called coccolithophores, and these lived abundantly in Cretaceous seas. At any given time, there were billions of these little microorganisms living their planktonic lives in the Cretaceous seas. And as they died, their tiny little calcareous skeletons would slowly descend and eventually settle on the ocean floor. If one could go back in time and go down in a deep submersible and watch the action, it would be like a constant, gentle snowfall of these tiny little skeletons. The only real question is, why were these coccolithophores so abundant in late Cretaceous seas? And for that, we need to look at the Cretaceous world, a world quite different from the one we're used to. A number of factors led to the explosion of coccolithophores in the late Cretaceous, and these had to do with climate, geography, plate tectonism, and ocean chemistry. Let's start with a brief look at Cretaceous geography. From the beginnings of the Cretaceous up until about 75 million years ago, world climate continued to get warmer, and sea level continued to rise, so that low-lying areas of continents by about 90 million years ago were flooded by shallow seas. It was in these shallow epicontinental seas that the vast chalk layers were laid down. Enormous reef systems formed on the margins of these epicontinental seas, but unlike today's reef systems, these were not dominated by corals. Instead, they were dominated by a bizarre and now extinct group of pelecypods called rudis. And here's a map showing the zone in which these reefs occurred. Throughout the Cretaceous, world climate was much milder than today, and temperatures continued to increase throughout the Cretaceous up until about 75 million years ago. During that period of chalk accumulation, 90 to 75 million years ago, it's thought that world temperatures were on average about 10 degrees centigrade higher than today. And perhaps you're wondering how that number is arrived at. Well, of course, the fossil record gives us a general indication that climate was milder in the Cretaceous because of the distribution of fossil plant and animal species. For example, fossil trees have been found in Antarctica. Fossil crocodilians have been found in northern Canada and Alaska. Fossil dinosaurs, amphibians, and so forth have been found in Australia at a time when Australia was not far from the South Pole. More directly, the temperature of ocean water can be determined with reasonable certainty by looking at the chemistry of fossil shells. That's because the ratio of two oxygen isotopes, oxygen 16 to oxygen 18, are temperature dependent in seawater, and organisms that construct calcium carbonate shells derive the oxygen from the seawater, and they incorporate the ratio in seawater at the time they lived. An examination of the calcareous shells of marine organisms from all over the world that lived during the late Cretaceous indicate that seawater was relatively depleted in oxygen 18, and this indicates that the temperature of seawater was quite high. As a matter of fact, a generalized map of world temperatures can be constructed. Now back to all that Cretaceous chalk. I want to talk about a couple of grand cycles throughout geologic history. For the last billion years or so, the Earth has fluctuated between an icehouse world, like the one we're living in today with permanent ice caps at the poles, and sometimes with vast continental glaciers, and a greenhouse world in which there's no permanent ice cap and very little glaciation throughout the world. And that long-term fluctuation between icehouse and greenhouse is reflected, as I alluded earlier, by the oxygen 16 to oxygen 18 ratios in seawater, as indicated by the calcareous shells of organisms living at various times in geologic history. There is also a long-term mineralogic fluctuation that touches on our question about the chalk, and this fluctuation tracks very well with the fluctuation of climate between icehouse and greenhouse. Calcium carbonate actually comes in two mineral forms, calcite and aragonite. Chemically, they're exactly the same, but their mineral structures are different and they form under somewhat different conditions. In the relatively cool waters of an icehouse world, calcium carbonate in the form of aragonite tends to predominate in the world's oceans, and organisms that synthesize aragonite as their shells tend to become dominant marine species. Conversely, in the warm tropical waters of a greenhouse world, species that synthesize calcite tend to predominate. With regard to the Cretaceous chalks, it was this greenhouse world combined with relatively high sea levels providing a vast favorable habitat for these little coccolithophores that allowed for the formations of gigantic chalk deposits. Alrighty guys, I hope you don't mind. I was a little more serious and a little more sciencey with this one. I guess it's because I, Pilgrim Pater, Potholer 54, and a host of other people have already pwned Neffy within an inch of his life. And I didn't want to talk about the Cretaceous because it's a fascinating period and a strange, strange world. I've only hit the highlights here, so I'm going to give you some reference material if you want to do more reading. And next time, I want to go back in time just a little bit further to the middle of the Cretaceous to talk about black shale and most of the world's valuable petroleum resources. Until then, bis später.
There'll be bluebirds over the white cliffs of Dover. Tomorrow, just you wait and see.
YouTube misfits, miscreants, malcontents, and misanthropes. Claire here, and I have received a request to address a few assertions made by that famous Conservapedia editor Nefellum Free in the most recent Magic Sandwich show. And these assertions involve geology, which is my field. So here goes. I'm going to attempt to avoid sarcasm, although it is tempting. We'll see how well I succeed. Alright, I'd like to start out with a few basic misconceptions that Neff brings to the table in any conversation, and he only has a few points, and most of them are just wrong. The idea that geologists think that all sedimentary rock strata were formed very, very slowly over a great deal of time, well, that simply isn't true. There are many sedimentary environments, and the speed with which sediment accumulates varies hugely. One thing I want to mention before I really start discussing sedimentary rocks is an odd obsession Nefellum Free seems to have with definitions of the terms strata or stratum and layers or layer. And I don't know where he got this odd idea that layers meant something vertical and strata meant horizontal. I have 6 years of advanced education in geology and field experience as a professional geologist. I've never heard that distinction, and I really don't know where he got it. In any case, I'm going to use strata and layer synonymously. I mean, most people do, except Nefellum free, apparently. Perhaps we should address some of Neffy's substantive points in the Magic Sandwich Show. The main point he had was that all sedimentary rocks display a vertical zonation of grain size, that is, at the base of the rock layer or stratum. The material is coarsest, and as one moves up through the stratum, the material becomes increasingly fine. That's true in some environments, particularly fluvial environments where streams are depositing sands or silts. It's not true of many sedimentary environments or many sedimentary rocks. Biogenic sediments like limestones often don't display anything like that. Many very fine sediments like clays don't display anything like that. It's more true to say that there's a zonation in terms of grain size as one moves farther from a sediment source. That is, the coarser material is deposited earlier, and as one proceeds farther and farther away from the sediment source, as the velocity of the water decreases, then the finer sediments settle out. There are all kinds of sedimentary environments that don't display the kind of vertical zonation of grain size that Neffy is asserting. Biogenic sediments in general, limestones, dolomites, don't typically display that kind of zonation. Evaporites, great thicknesses of evaporites don't display anything like that because they don't have individual grains. The famous chalks of the Cretaceous don't display that sort of zonation because the entire formation is made up of billions and billions of shells of these little microorganisms called coccolithophores. And it doesn't matter if you look at the base of the formation or the top, all the grains are the same size. And it's not just biogenic sediments and chemical precipitates that don't display this sort of vertical zonation. Some clastic sediments don't display it either. Conglomerates, breccias, glacial till. They're not sorted by size if you go vertically through the rock column. In short, Neffy's just talking out of his ass. Neffy's view of the sedimentary rock record of the planet is of course heavily informed by his sad adherence to a Bronze Age superstition involving a worldwide deluge. His adherence is so strong he's willing to ignore the incredible complexity of the sedimentary rock record, preferring instead a simplistic belief in a vertical zonation of sediments with the coarser material deposited at the base when things were active and violent and the flood was taking place, to finer sediments as we move up the rock column when things were peaceful and Noah's Ark was bobbing on the waves and about to find a portage on Mount Ararat. I'll cite a single example from the rock record to illustrate how silly that is, and it's the Michigan Basin. There you have about 15,000 feet of sediment, all kinds of rocks representing a wide variety of sedimentary environments. Sandstones, siltstones, shales, limestones, all interspersed. Evaporites, multiple erosional unconformities. Now, there are two interpretations, I suppose, that are possible. One is that basin gradually subsided over many millions of years, allowing 15,000 feet of sediment to accumulate. Or a view that there was a 15,000 foot deep hole filled in by sediments from the flood. I'll leave it to you to decide which is the more reasonable. Before I go, I want to address one other mention that Nefellum free made. Something called polystrate trees, well, what are polystrate trees? The etymology of the term's a little mysterious. No one knows who coined it. It's not really a scientific term, and these things have been known as long as we've been mining coal. What they are tree stumps. And they cut through multiple rock layers or strata. For a young Earth creationist like Nefellum Free, they imagine this as some sort of conundrum for modern geology, because they have a fantasy that geologists think all rock layers took millions of years to form. Well, nothing could be further from the truth. Let's consider where these trees are found. They're found in coal-rich deposits where coal formed. They're formed in swamps. Where are swamps? They're usually in floodplains. What are floodplains? Floodplains are low, flat areas adjacent to streams, and they're areas that are frequently flooded. Any flood event can deposit several feet of sediment, so it's not difficult to imagine that a tree stump could be very quickly covered by flood deposits. That's it. It's that simple. In closing, I just want to say that my very real impression is that Nefellum Free's sole knowledge and experience of sedimentology and stratigraphy are derived from his view of a YouTube video of a couple of guys playing with a sand table. And a sand table is simply a piece of equipment often used in freshman geology to illustrate some basic concepts of hydrology and stream erosion and deposition and the formation of deltas. Well, the fields of sedimentology and stratigraphy are far more complex than that. Watching Nefellum Free do geology, well, it reminds me of something I once saw involving our great basketball coach at UNC, Roy Williams. After he had been asked for about the 50th time by some numbnuts reporter, had he considered this, that, or the other strategy, he fixed the reporter with a cold stare and said, "I do this professionally. I do this for a living. Neffy, I've been paid to be a geologist. I've worked in this field. Can you say the same?"